Hi, this is John Bridges. Welcome to my capstone presentation. The title I gave for this project is Pedagogical Factors that Influence the Design of a Computer-Aided Drafting Class. And I've been very interested in this because I am an instructor out at Lane Community College and I teach computer-aided drafting. So going through this master's program, I wanted to find out what would be the most appropriate way that you could teach students effectively the CAD software. And because the technology is constantly changing in the drafting industry, as teachers we also have to be constantly looking for new ways that are effective to teach students this new software so they can go out and also learn new software on their own that we haven't even seen yet. Before I get started with the presentation, I'll give you a brief introduction to myself. I've been married for 39 years to my best friend. I have two sons who are both on active duty in the Air Force overseas right now. And I have two grandboys that I was able to spend the summer with this summer. My education, I received a Bachelor of Management degree from St. Mary's College in Moraga, California. My military experience has been about 14 years as a flight engineer on C-5s and C-130s, way back when. And my professional experience started off in architectural and construction industry. I've been everything from a builder of furniture, custom furniture, to a designer and project manager. 13 years ago, I was hired out at Lane Community College as a drafting instructor, and that currently is where I'm employed now, and I'm really looking forward to applying this knowledge that I've gotten from this master's program at NCU. Drafting has been a very important part of manufacturing and building for thousands of years. It's always been a means for someone to graphically convey the process of taking an idea to the reality of the part being made, or a building. Some of the earliest tools included charcoal on cave walls, ink on rice paper, and finally pencil and ink on paper. Manual drafting combines the tools of paper, pencil, scales, T-squares, and triangles to produce flat two-dimensional views of an object onto a sheet of paper. With the evolution of technology that we have nowadays, we can use computers for creating 3D models of a project. This allows a viewer to inspect all the parts, even on the inside, as they're moving within a machined assembly, or they can even take a virtual walkthrough of a multi-story building. Now, there have been a lot of studies conducted about the emotional responses to technology and also the different effects that they have on the students' learning styles. So in my literature review, what I found was an example here by Maurer, and he explains that there's a direct correlation between the length of experience with technology and the level of anxiety a user experiences. So the more experience people have with the technology, the less anxiety they felt. And using this technology for learning sometimes brings out different responses from different students. Some of them are excited, eagerly embrace the new technology, while other students are hindered from learning because of their anxieties about the technology. And I know from my own observations, I've concluded that some students are also intimidated while they watch other students around them who are quick learners or who enjoy learning a new software program or have used it in the past and are real comfortable with it already. They feel awkward and even embarrassed at times to show their lack of abilities. But our job, and that's why my job as an educator, should be to make teaching and learning more productive and efficient, and so that we can enhance the students' learning experience. One interesting thing that I found in my literature review has to do with the learning styles, and that they are actually many different learning styles, and they can be categorized basically into three areas. There's perceptual, cognitive, and affective. And the perceptual learning can be further divided into 7 ways that a person absorbs information. That's why it's important that you understand these as a teacher, so that you can effectively teach to different learners. We have the oral, which is listening, the haptic, which is touching or holding. There is interactive, which is verbalizing and discussing with others. Kinesthetic, which is body movement. Olfactory, which is our sense of smell. Through print, which is like reading and writing. And the last one is visual, viewing pictures, images, objects, and activities. Okay, we can also see from some of the literature that I reviewed the ways that teachers see students learning. And one of those ways, learning is seen as acquiring knowledge through the use of study skills in preparation for a task. Learning is seen as being able to absorb new knowledge and then be able to explain or apply it. Learning is the development of thinking skills and the ability to reason. Learning is developing skills necessary to become proficient. Learning should be a means for changing personal attitudes, beliefs, and behaviors in response to different environments. And then learning should be a participative pedagogical experience. So in my literature review, what I found that students need is a variety of teaching strategies. They need a variety of learning paths. And all this is because of these different learning styles that we see. They need activities that they can read, visualize, hear, say, and do. They need some instructional scaffolding. Students need the ability to work on their own with appropriate assessment methods. And they also need appropriate tools and technology for their own independent or guided study. The technology in education, I found in this research, should be used to teach these different learning styles. It also needs to facilitate learning. It should be part of the instructional process and not just be something that we add on as an appendage during any convenient stage of the instruction. So that means the instructors need to be familiar with the technology so that they can be comfortable with it and be effective with it. This is a quote that I've found. Using technology to enhance the educational process involves more than just learning how to use a specific piece of hardware and software. It requires an understanding of the pedagogical principles that are specific to the use of technology in an instructional setting. Very important that we don't just learn how to use the software as a tool, but we learn how to be specific in the use of the technology in the instructional setting. In 1994, Barbara Means pointed out that technology training must go beyond focusing on the acquisition of technical skills, and that attention should be given to the instructional strategies needed to infuse technological skills into the learning process. Now, learning CAD involves many areas of cognition. The learning materials we develop for students should be cognitively well designed, so we need to spend the time to do that. It's important that these materials are provided in a variety of forms that will match well with the different student learning styles that we've just looked at. So our purpose as instructors should be to devise pedagogy material that reduces the cognitive load on students. And as stated by Ford in 1999, just as an ergonomically designed chair is well adapted to the physical requirements of its user, so a cognitively ergonomic learning resource is well adapted to the learning requirements of its user. Our job as educators and administrators should be to continue to search out the best ways to teach, implement, and maintain current technologies in our classrooms. Teachers also should be responsible for encouraging students to keep pace with a rapidly changing industrial environment and to realize that learning is a lifelong experience. To begin this journey in a student, the teacher needs to minimize the use of direct instruction and become more of a facilitator in the student's learning process. Constructivism is a learning theory that's been used in K through 12 classrooms for many years, and I found that it has applications for teaching drafting also. Constructivists do not view knowledge as truth, rather knowledge is a working hypothesis, since in their view, Knowledge is not imposed from outside people, but rather formed inside them. Another constructivist premise is that teachers should not teach in the traditional method of direct instruction to a group of students all at the same time. They feel that students should be placed into a situation so they become active learners and involved with the content of learning through manipulation of materials and having social interaction. So we are expecting them to have a collaboration within the classroom. It's also recommended these activities include observing phenomenon, collecting data, and working collaboratively with others, as I just said. The theory of constructivism involves students actively in their learning experiences to challenge their thinking and possibly a rearrangement of their own beliefs. The use of constructivism in teaching CAD will probably be an effort for some teachers. For example, instead of the teacher regurgitating the subject matter from textbooks or creating hypothetical questions or giving the students objects to draw and then presenting the content to the students through direct instruction like our lectures, the teacher will need to assume the role of a facilitator in the learning process. Learning in a constructivist setting is not allowing students to do whatever they want, which some people think. That's why they haven't tried it. That's why they don't pursue it. But the environment that they're in should engender rich experiences that encourage the students to learn. Stipek wrote in the Handbook of Educational Psychology that engaged students are more likely to approach tasks eagerly and to persist in the face of difficulty. They're also more likely than disengaged students to continue their learning after formal schooling has been completed. When a student's given choices and the opportunity to find value in creative design activities, the result is purposeful learning. As we can see from a quote from Sheldon and Biddable in 1998, if students are challenged, if their interest in the subject matter is encouraged, if they're given autonomy in their support, then their intrinsic interests, their motivation for learning, and even their test scores will all grow more effectively. While I was working on this research project, I noticed some consistent themes that seem to relate to the teaching of computer-aided drafting, especially in the context of these changing technologies. For instance, should manual drafting still be part of our CAD curriculum? How important are visualization skills to drafting? And also, what are the most important characteristics that a good drafter should have? So I want to answer some of these in the next few slides. Now, typically a set of these plans that's produced show multiple views of an object, along with any necessary dimensions and annotations. These plans are then used by many different people within the design and manufacturing and construction industry. Now, some of the skills that a drafter needs in order to produce a good quality set of these plans is problem solving, visualization, accuracy, collaboration with many other professionals, and good communication skills. Now, traditional drafting curriculums focused on developing these and other skills within students that were enrolled in engineering and drafting classes. However, since the introduction of computers as a tool for drafting, there have been many that have questioned the need for manual drafting skills. There are those who believe that a world with CAD has no place for drawing boards, T-squares, and triangles. Others argue that students need to know the basics of technical drawing before they venture into CAD. Now, during my research, I found some interesting information that was very helpful. David Field argues that knowledge of drafting develops thinking in 3 dimensions and communicating in 2 dimensions. He also suggests that a drafting curriculum should include an emphasis on the creation of solid geometry to help develop spatial reasoning skills. Another good resource was from Sorby and Gorska. They claim that hands-on sketching and drawing tend to improve spatial skills more than courses that stress CAD methods. They suggest the physical nature of the drafting experience develops a deeper understanding of the meaning of lines and symbols on a page and helps to develop the ability to make mental conversions into 3D realities. Manual drafting also encourages critical spatial thinking and visualization. And I know in my own experience with teaching beginning drafters, I can attest to this lack of their visual skills. I'll usually hand out an instruction sheet with an image for them to complete. It's going to be a drawing of some kind. But when I ask them to produce an alternate view of the same drawing, then they're not able to do it. They fumble. Redford describes this as a surface learner syndrome and observes that beginning drafting students tend to copy what they see and they lack a genuine visual understanding of the actual object. And one of the reasons that has been speculated that students have some sort of challenges with learning CAD comes from Saul Olkin, who discussed the role of geometric activities to enhance spatial abilities in students. And he suggests that not enough time is allocated to what's called transformational geometry. This is especially true in the traditional math curriculum, where they don't really cover this a whole lot. But it's very important in spatial skills and understanding an object. When it moves, when it rotates, when is it scaled up or down, what changes in that object? What are the sizes of the different sides of that object and how they relate to each other? He also discusses the importance of physical and mental manipulation and the representation of objects in 2 dimensions and 3 dimensions to develop both the ability to solve these spatial relation problems and the more complex spatial visualization tasks. He also proposed that the representation of 3D objects by 2D diagrams requires a cognitive understanding of the whole part. And that's what I think gives most students a hard time when they're learning CAD or in the drafting program, that they have to have the ability to visualize a 3-dimensional object and to be able to display that object in only a flat 2-dimensional surface. So sometimes it can be pretty difficult, but that's why with the advent now of the advances in technology and computer-aided drafting, they can create a solid model. And what happens is that the program that they use, the CAD program, will develop the 2-dimensional drawings for them. Now, besides learning the user interface of a CAD program, that means all the commands, pull-down menus, toolbars, things like that, and developing the spatial and visual skills, student drafters must also learn drafting conventions that are used in the industry. And these are different depending on whether in mechanical, civil, or architectural industry. And these conventions mean what type of text font to use, what type of line type, how thick should the line be, what are the layer names, and things like that. I've had conversations with members of our drafting advisory committee who say that even they're noticing a decline in the quality of drawings that they review. What they suggest is that drafters today lack an understanding of the basic geometry construction and these conventions of drafting standards. One of the things I found in my research was the Ullman, Wood, and Craig argued that the importance of both manual drafting and informal sketching as necessary problem-solving skills are required at various times during the design process. They claim that the additional cognitive load of learning and implementing a CAD system is what hinders this design process. So there's almost 2 different things that a student has to learn. Besides the interface and the use of all the tools in the CAD program, they need to have the cognitive skills and develop these spatial and visualization skills. I noticed in doing my research that there does seem to be a consensus that the teaching of CAD should have more emphasis placed on visualization strategies rather than on the commands and the features of the software. And I saw from Sorby and Gorska that they argue that traditional manual drafting is an effective means of developing these spatial visualization skills, and it improves the performance with their spatial reasoning. Now, as I've said, the introduction of CAD has challenged the whole premise of drafting and the need to learn principles of manual drafting. Originally, the drafting courses were designed to teach students how to correctly represent the different views of a 3D object onto a flat piece of paper, and we've already talked about that. But in 2003, Catalyst magazine published an e-survey in their April-May issue that invited feedback from their readers. And they asked if school students should still be taught manual technical drawing, because computer-aided drafting had obviously been the norm at that time. The respondents included industrial CAD drafters, architects, engineers, CAD managers, technology teachers, and even university professors. Now, from this sample of respondents, they had 374 people in this from the industry. So 87% of them expressed the view that students should first learn to draft with paper and pencil before progressing to CAD. The majority of the responses also indicated support for teaching the fundamentals of orthographic projections through manual drafting, and that manual drafting provided a solid grounding in terms of knowledge and of understanding the concepts for drafting. Now, the survey left space for the respondents to make comments, and what was interesting is that these comments were related to attitudinal values developed through the process of manual drafting, and these included perseverance, patience, discipline, appreciation of the advantages of new technologies, extra special care for precision, the importance of planning, and artistry in composition and layout for the purposes of clarity. It's also interesting in this survey to read the comments that were left by some of the CAD instructors. These included, students had a poor understanding of the fundamentals of constructing a drawing. Students lacked confidence in sketching. And also, students lacked an appreciation of complying with rules, standards, and conventions. Now, even some current students in a drafting program provided feedback in the survey. The majority of them said that they agreed learning to do manual drafting first would help while learning CAD. A large majority agreed that CAD was more fun and exciting. Students who had completed a manual drafting course associated more ownership to their manual drawings as opposed to a drawing produced by CAD. All the students were clear about their reasons for learning CAD: staying current with technology, future career prospects and opportunities, variety, accuracy, speed of production, quality of output, and ease of editing the drawings. Now, a summary of the themes that emerged from this survey identifies some key aspects of learning. One being cognitive development, the understanding, the thinking skills, our spatial awareness, visualization skills, and the relationship of how different views of a projection relate to each other. Also, knowledge development, which is the application of the basics of drafting conventions, our standards, the layouts, the drawing types, our measurement, and the scale that we use. Our psychomotor development, which includes coordination, control, accuracy, neatness, and the general discipline of drawing. And finally, affective development, which includes motivation, the ownership, artistry, care, and the enjoyment of doing the project. The survey appears to show some strong agreement between industry teachers and students that there is still value in learning how to construct and draft technical drawings manual. And so what happens is, the issue is what type of pedagogy to include new technology with these older manual drafting skills. And that's one of the issues that we're having to deal with out at Lane Community College. Now, while we're talking about drawings, what I found out was that there's a design graphics division of the American Society for Engineering Education, and they've adopted a model for engineering graphics which identifies 3 levels of drawing. And this is important in the whole drafting field. The first type is ideation drawings, then there's communication drawings, and finally the documentation drawings. Now the ideation drawing is usually freehand, it's very informal, it's like sketching, and it's used as a way of communicating between the different professionals, between a drafter and a designer, between engineers. And what they're looking for, it's a way of visually brainstorming ideas to get to a solution to some problem, to figure out how this part should be built, how the building should look, and many ideas can be communicated this way before you spend a lot of time developing a drawing. The second level is communication drawings, and these include a variety of drawings like perspectives, renderings, technical illustrations, and sometimes they'll have artists involved in these instead of, well, there's many people that could be involved in creating these types of drawings. The intent with communication drawings is to develop promising ideas and then communicate these ideas to colleagues, either clients or other interested individuals, even other engineers, designers, architects. There's currently many computer programs that will provide a fairly realistic representation of the objects using color, shading, lighting, and texture so that you can get a fairly realistic idea of what the finished product should look like. And then the third level is the documentation drawings. These are also called working drawings, shop drawings, or engineering drawings. These drawings are governed by a strict set of standards, which we've looked at, called conventions, and usually consist of orthographic projections with dimensions and text inserted. Now, it would be possible within a CAD drafting class to include more emphasis on visual skills, such as freehand sketching, in conjunction with technology, such as the computers and the solid modeling software, and it would satisfy the requirements of all three types of these drawings. So instructors could teach the basics of orthographic projection or multi-view drawing, first using freehand techniques, and then teach the use of appropriate CAD packages in the production of the final documentation or working set of drawings. So in concluding this presentation, I found that designing a dynamic classroom using technology requires that teachers provide a learning environment that is engaging, it's exciting, it's interactive, and it'll encourage students to step into the world of technology and to discover knowledge for themselves. Some of the recommendations that I've found to consider when designing an effective CAD curriculum should include all types of drawing, the ideation, communication, and documentation into the curriculum. CAD alone is not adequately prepare a student to become an efficient and effective drafter. The goal of technology education should be to teach students to be self-learners and develop quality problem-solving skills, not just to train CAD workstation operators. Emphasize freehand drawing techniques for ideation and communication. The basics of orthographic systems can be taught with technical sketching. Use the most current versions of a CAD software program to produce documentation drawings. The brand of the software is not as important as learning the concepts. And finally, acquaint the students with the concepts of 3D solid modeling, since this is the future of design, manufacturing, and construction. During the course of this research, I actually found many other questions that I wanted to continue to look into, but just thought I'd share three of them here as a result of this research. One of them being, how can we evaluate the drafting industry to determine what we should be teaching our students in our curriculum? We want to make sure that our drafting students are current with whatever is out there in industry, so we need to find out ways of making sure that that happens. Another one is, since visualization skills are so necessary for a drafter, what strategies or technologies can we use to improve these skills in the students? And another one was, do students learn software most effectively by working independently or in small groups, working on a long-term project or on multiple non-related exercises? So we need to look into ways that we can try all of these to see which one would be most effective. Finally, it's important that teachers use a variety of teaching methods Students should be taught to use these newly acquired skills and knowledge to critically evaluate and modify their own knowledge as they progress in their future careers. As teachers, we should be able to engage students in an exploratory learning experience which is designed to constantly stimulate their thinking and learning.